Okay, so here is number 5. And I just realized that, shoot, sorry. I just realized that I might have been too close before. So hopefully you saw the whole board. I didn't go back at these and look at them again. Um, so if you're missing anything, let me know. All right. This problem, your teacher did not give you this problem because she hates you. Your teacher gave you this problem to try to recognize patterns, right? So, what happens with this is it actually simplifies and comes out really nice. And mathematicians love that type of thing where these really ugly problems simplify into something that is very simple. Um, so, in order, right? You can use your distributive method. You can use the tabular method. In this case, I would say the distributive method is probably the easier route. Keep things organized and don't get lost with it, and just to go step by step, right? And um, try to keep things in order, and then you'll get the problem right, right? So you're gonna take this x, you're gonna multiply by every single x in this pattern, right? I call it a pattern because that's what it's going to end up being. You're going to have x to the 12th, 11, 10, 9, 8, 7, 6, blah, blah, blah. That's how it's going to go when you multiply these together. You can do it the long way, or you can just recognize the darn pattern. Um, and there's nothing wrong with not recognizing the pattern right now, right? I recognize the pattern because I've been doing mathematics for years, right? So don't worry about keeping up. Start x times x to the 11th. Get out of here. You're going to do x times x to the 11th, right? That's going to be x to the 12th because it's 11. 11 plus 1, right? You're going to do x times x to the 10th. That's going to be x to the 11th. X times x to the 9th. That's going to be x to the 10th, right? X times x to, oops, getting ahead of myself. X to the 8th. And I might run out of room. That's when I'll start doing the dots. X to the 7th, x to the 8th, x times x to the 6th, x to the 7th, and so on, and so forth. Sloppy is as sloppy does. Alright, so that's what we end up with on the x side. So now you got to do it this negative 1. So negative 1 gets distributed all the way through this garbage, right? And I'll do that over here. So this is negative 1 times x to the 11th. Well, is that? That is negative x to the 11th. And this should be an easier pattern to see. Right? So I'm not going to do all this. X to the 9th. All the way down, right? You got x, negative x squared. You got negative x. You got negative 1, right? This is the end. 9, imagine that these dots in the middle are the rest of the sequence, and you end up with these last couple of terms. So what do you see? This is the important part of the problem, right? What do you see? You see that when it's time to combine like terms, right? Everything cancels everything else out, pretty much, right? Combining like terms to the nth degree is what's going on right now. So you have an x to the 11th, you have negative x to the 11th. So negative 1 plus 1 is 0. That cancels. Guess what? 10 cancels, 9 cancels, 8, 7, 6, 5, 4, 3, 2, and 1 cancel out. That's what this problem turns out to be, because you have a negative for every positive that's over on this side, except for this first term. So in the end, what you're ending up with is x to the 12 minus 1. That's your problem, and that is the joke that mathematicians have just played on you with this ugly problem. And by the time you end up finishing marking up all your paper, you're probably mad, but it's kind of satisfying in a way too. Maybe not. Maybe you just hate it. I don't know. But that is this problem. And we're done.